My dear friends, here it is given to calculate the pH of 0.1 m ammonia solution and also to calculate the pH of a solution after the treatment of 50 ml of this ammonia solution with 25 ml of 0.1 m HCl. So let's segregate this question into two parts. In part 1, let us calculate the pH of this 0.1 ammonia solution. We all know when ammonia is treated with water, it produces ammonium ion and hydroxide ion. As per the question, initially we have 0.1 m ammonia and the concentration of ammonium ion and hydroxide ion will be 0. So if one ammonia produce one ammonium ion and one hydroxide ion, so X ammonia will produce X ammonium ion and X hydroxide ion. So when X amount of ammonia is reacted, so the left concentration of ammonia in the reaction mixture will be 0.1 minus X. So initially it was 0, X amount is produced, so it will be X. Similarly, the concentration of OH minus will also be X. So putting the values in the expression Kb is equal to, we all know, that is the product of molar concentration of the products divided by the molar concentration of the reactant. So putting the values from the given expression, 1.77 into 10 to the minus 5 is equal to X square divided by 0.1 minus X. Here we can see the value of Kb is in the multiple of 10 to the minus 5, which is very small, and as the value is less than 10 to the minus 3, we can say the reaction is just started. So this X must be much more less than 1, and 0.1 minus X will be nearly equal to 0.1. So when the 0.1 is multiplied on the left hand side, it will become 1.77 into 10 to the minus 6. So now we have to find out the value of X, which is the square root of 1.77 into 10 to the minus 6. We all know the square root of 10 to the minus 6 is equal to 10 to the minus 3, and this 1.77 can be written as 177 divided by 100, and the square root of this must be square root of 177 divided by square root of 100, that will be 10. So now we have to find the square root of 177. So there is a easier method, and we all know the square of 14, that is 196, and the square of 13, that is 169. So if we find the difference will be 27. Again we have 177, and if we subtract this value from 169 from 177, it will become as 8. So 27 divided by 8 is nearly equals to 3. So our value must be 13.3 or 13.4. So let's try out. If you take 13.3, it will become as 176.89. If you take 13.4, the value will be 179.56. So this is more correct. So we can say this value will be 1.33, because this is square root of 177 divided by 10. So that will be 1.33 into 10 to the power minus 3. Now we have value of X. This X is the concentration of OH minus ion. So we can say the POH is equal to minus log of concentration of OH minus ion, which is 1.33 into 10 to the power minus 3. So we all know again log AB is equal to log A plus log B. So this is equal to log 1.33 plus log into 10 to the minus 3 multiplied by the minus. Again 1.33, we all know 0.33 is nothing, that is 1.1 divided by 3. So 1.33 will be 1 plus 1 by 3, which is equal to 4 by 3. So this will make our calculation easy. So this log 4 by 3 plus, we all know log 10 is equal to 1, and the formula is equal to log A to the power B is equal to B log A. So it will be plus 3. Again log A by B is equal to log A minus log B. So this will be equal to log 4 minus log 3, but here we have a minus sign, so this becomes log 3 minus log 4. Again we all know the log 3 is 0.48 and log 4, that is 0.6. So this will become as 0.12. So 3 minus 0.12, that will be 2.88. This is the value of POH, but we have asked the value of pH at 298 Kelvin. The pKW is equal to 14, which is equal to pH plus pOH. So pH is equal to 14 minus pOH, that will be 11.12. Coming to the part 2, we have provided 50 ml of 0.1 m HCl, 50 ml of 0.1 m ammonia solution and 25 ml of 0.1 m HCl. So in 50 ml of 0.1 m ammonia solution, what is the total number of moles? We all know 0.1 m, that means 0.1 in 1000 ml. So in 1 ml that will be 0.1 into 10 to the minus 3. So in 50 ml that will be 50 into 0.1 into 10 to the minus 3, which will be 5 into 10 to the power minus 3 mole, or we can say 5 millimole. Similarly, 25 ml of 0.1 m HCl, that will be 2.5 into 10 to the minus 3 mole, or 2.5 millimole. So initially there will be concentration of ammonium and chloride ion will be 0, but after the reaction, here you can see the number of HCl is less. So this is the limiting reagent which will decide the amount of product formed. So we all know 1 HCl produce 1 ammonium ion. So 2.5 millimole HCl will produce 2.5 millimole ammonium ion and 2.5 millimole Cl minus ion. Again 1 HCl react with 1 ammonia. So 2.5 millimole HCl will react with 2.5 millimole ammonia. So the concentration of ammonia will be, initially it was 5, out of which 2.5 millimole was reacted. So the new concentration will be again 2.5. 5 minus 2.5 is equal to 2.5. So when this ammonium ion and ammonia, again there will be equilibrium. So we all know ammonia plus water gives rise to ammonium ion and hydroxide ion. Here what will the concentration? It is the number of mole, but the total volume is equal to 50 plus 25, that is 75 ml. So concentration is equal to 2.5 divided by total volume. Here also the concentration of ammonium ion is equal to 2.5 divided by 75. So at equilibrium, X amount of ammonia will reacted. So 2.5 divided by 75 minus X, and here X amount of ammonium will form. So this will be 2.5 divided by 75 plus X, and initially it was 0. So 0 plus X is equal to X. Now we all have that Kb expression. Kb is equal to concentration of ammonium ion into concentration of OH minus ion divided by concentration of ammonia. The Kb value does not changes by varying the concentration, so it will remain constant, that is 1.77 into 10 to the minus 5. Again putting the values of this concentration terms, this will be this equation. Again we all know the value of X is very small. So 2.5 divided by 75 plus X is nearly equals to 2.5 divided by 75. Similarly, this value is also equal to 2.5 divided by 75, because the value of X is very small. So this will be cancelled out. So we can find the X is equal to 1.77 into 10 to the minus 5. Again this is the concentration of OH minus ion. So what will be POH? POH is equal to minus log of concentration of OH minus ion, which is 1.77 into 10 to the minus 5. So again log AB is equal to log A plus log B, and multiplied with minus, this will be minus log of 1.77 minus log of 10 to the minus 5. This value will equal to 5. Again here we have 1.77, let we take it as 1.75, or 1 plus 0.75. We all know 0.75 is equal to 3 by 4. So this will be 7 divided by 4. This will again make easy our calculation. So this will be minus log of 7 by 4. We all know log A by B is equal to log A minus log B. So multiplied with minus, this will be log 4 minus log 7. The value of log 4 is 0.6, while the value of log 7 is equal to 0.845. So this will give 4.755. This is the value of pOH. But we all know again at 298 Kelvin, the pKw is equal to 14, which is equal to pH plus pOH. Now the pH will be 14 minus pH, that will become as 9.245. So try to use these tricks while we are calculating, otherwise it will take a lot of time, and it will be very difficult to get the accurate value during the examination. Thank you. Happy learning.